Hello, my name is Ariyan Jalilian, and this is my EECS 1021 bonus project submission. As you can see here, this is my code for the bonus project. I imported all the necessary libraries here. I decided to make use of JFree charts. I did a little bit of searching online, and according to both Google AI and a quick subreddit search, it is a decent chart maker and simple to use in Java. Over here, I'm starting the overall class. I set up all the necessary pins and whatnot. Set up a logger which will just keep track of related variables. These will be keeping track of the I/O devices, the hash maps, the necessary thresholds for this, since we are handling levels where materials become safe versus unsafe, certain quantities of carbon and VOC. Here I am setting up time series for both the CO2, the VOC, and humidity series here. And a schedule as well, scheduler. Here I have the main method started up. I set up and initialize the board here. Force of habit, I always set up the board first itself. I set up the thresholds for the modules, the Arduino modules here. So if the amount the modules are detecting goes above that amount, the graph will put out an alert message warning the user that the thresholds are being crossed and there is too much of certain materials in the air, CO2, humidity, whatnot. Here I have the pins on the Arduino board set, and then making sure they're set to analog here. I set up the chart and I constantly updated it here as well with this simple 2 lines. These are the smaller methods that I use to set everything up through. So this one sets up the charts, gets data from the sensors to put onto the graph. Here it sets up the title, axis, and legend of the graph. And here it's putting everything together onto like one larger thing. This code constantly updates the graph over time. So essentially every like few milliseconds, now that there's new data coming in, it'll attach time to that. It'll find the new information and put it to the side. Where here is where basically most of the work gets done. Constantly checking over and over again. That converts the readings from the sensors to proper units so we can understand it easier. This is just for diagnostics. If anything happens, this will keep track of it. I pull the current time of day here and then assign the current time of day to the corresponding value we've gotten from these sensors. And then we double check to see if anything's crossed the threshold. This will give the user a notification when the threshold is being crossed. This shuts down resources. Make sure everything closes properly when you exit the code. This displays all the information on the screen. So this is just constantly updating the graph as time goes on, ensuring everything's running smoothly. And now let me run the code to show you how it works. In one moment, the thing should pop open. Here we go. As you can see, over time, the x-axis is increasing in points. Eventually, it will start to decrease somewhat just because as time goes on, more points will be made. So some points will be sacrificed. As you can see now, it's every 5 or so minutes. The y-axis stays relatively stable, as I've set it to be. And then if it were to hit above a certain threshold, a small little box would appear in the middle of my screen that I would not be able to access the rest of the graph until I close it.